Hi, I'm Jake Warner. I'm Cycle.io's CEO and founder. If you haven't heard of Cycle before, Cycle is a container orchestration and infrastructure management platform built to be a true alternative to Kubernetes. I wanted to record a video today to talk about a new feature that we had just released. This is a feature called Functions. If you've ever used AWS Lambda or serverless framework, Cycle's approach to functions is very similar. There are some differences, which we'll kind of dive into during this video, but in general, there are a lot of similarities. As I mentioned, this feature has just been released, and so this is kind of a beta release to it. We wanted to be able to get it into the hands of our users, so that way we could learn more about how our users are going to use functions, and how we can, as time goes on, make functions better, and what direction we want to take just what features we want to add to functions. So let's dive in. So for this demo today, we're going to be using Cycle's portal, but it's important to note that there are a number of ways you can interface with the platform. You can use an API, etc. Everything can be fully automated, but yeah, it's, for the sake of the demo today, we'll just dive in via the portal. So first, we're going to jump over into environments. An environment in Cycle, you can think of it as like a global VPC. Each environment is a private network, fully encrypted. Each of these environments can span different regions. They can span different cloud providers. They can even be extended into like on-premises if you're running like bare metal in a rack in your office or something like that. Cycle's environments can be extended into that as well. But yeah, so we're inside of this environment. You can see each environment has a couple services built into it, and we'll dive a little bit more into those later. But let's jump into containers. So all of these containers that we see in this demo environment are long-running containers. So some of these are stateless, some of these are stateful, but yeah, they're just always running. Let's go ahead and deploy a function. So a function in Cycle can be any container, right? So we're going to name this getting started. We'll make it stateless because we don't really care about persisting any data. And then we're going to choose function as our deployment strategy, and you can see the little beta tag for that here. So we'll choose function. Let's say we want to start with 10 instances of it. And let's choose our getting started image. Let's make it publicly accessible. Let's listen on both 8080 and 44380. That way we can accept HTTPS traffic. And we'll go ahead and click deploy. As we deploy this container, we can see that Cycle built 10 instances of it. So we can see here that in this case, Cycle dropped all of those over onto AWS, which is perfectly fine. But you can see that Cycle saying, hey, you told us that this container needs to be publicly accessible, and it's not because we did not associate a domain with it. So let's go ahead and do that. We're going to jump over to a domain that we have on our dev cluster here. You can see that I have a domain here called getting started. And let's go ahead and associate that with our getting started container. So I'm going to use a linked record. A linked record in Cycle is very similar to an A record or a quad A record, except instead of having to manage IPs, you're pretty much just telling Cycle, hey, this domain needs to point to just a container, and Cycle will figure out the rest of it. So we're going to go ahead. We already have TLS certificates generated for this container. We'll click update. There we go. We've associated this domain with that function. And now if we go ahead and let's actually just navigate to it. I'm going to refresh. It was cached. I had hit this previously. There we go. Let's go back to our environment. And we can see that because I hit that in my browser, we have an instance up and running. Great. So I'm going to go ahead and close this. And I'm going to pull up a terminal over here. And so I have this quick little script that I wrote. So in this case, this is just going to create 100 HTTP clients. Each client, we're going to create 100 clients. We're going to run 20 at maximum concurrency, and then we're going to run 20, or each of those clients is going to make 25 requests. So if I do go run test.go, give it a second to compile, and we should start to see these requests or these instances start to be, they'll be started, they'll be stopped, they'll be started again to handle those requests. And so this is one of the neat ways the Cycle is allowing functions to actually occur really quickly, is that instead of creating and then deleting, Cycle is pretty much starting and then resetting when it's done. So that way it makes it really easy really quick for them to start. And so why would you use functions? You can use them for whether you're processing like HTTP or inbound HTTP requests for like batch processing, or maybe you're re-encoding a video, or you're resizing images, or you're sending like if you're a company that builds or that is like providing like an email service, anytime you might have a user send out like a mass mailing to a whole bunch of people, being able to spin that up in a function, have that function handle that, but then be able to handle that concurrently for a different user at the same time via another function. The point is there's many different ways of how you can use these functions. So obviously this specific example is just using functions by literally hitting an HTTP endpoint, which is pretty simple. We see a couple of these timing out, but that's okay, just because I've purposely limited how many functions that we're going to run in parallel, so we can see that they're timing out, and we'll solve that more in a second. So right now, because again, we only created 10 instances and we're running 20 concurrently, and we have not enabled auto scaling or things like that. But now that this is getting close to being completed, actually, I'm just going to stop it for the sake of making this video faster. Let's go ahead and scale this up. So right now we went from 10 instances. Let's take it up to 30 instances. And let's scale that. And so now we have, there we go. So now we have our 30 instances. I'm going to refresh. Portal didn't update that. There we go. We have our 30 instances. So if I were to run that same request again, we should see not only it happen faster, but we would obviously see less failures as well, because we have much more capacity. Again, I'm going to stop that just for the sake of keeping the video kind of moving. And one of the other things that I want to show here that's really cool about this approach is that if I go back into the environment dashboard itself, we can see we have our scheduler here. Now, the scheduler that is part of this environment is handling all of the scheduling for these functions. And the scheduler, even though we're using Cycle as a way of orchestrating all the infrastructure, etc., the scheduler is orchestrating the functions within this environment, and it's doing it on top of your own infrastructure. So that way it's very, very fast. Now, if I go to manage that scheduler, we don't have any telemetry yet because, again, this is all in beta, but I can go over to instances, and let's go ahead and start another instance. So we're going to say new. We'll start another instance. So that first scheduler is over on Vultr, because like maybe your scheduler is a throttle point within, if you're getting a huge amount of traffic and you want to be able to handle more of that. So we can add another scheduler here. There we go. And you can see that just adding that other scheduler, Cycle automatically resharded how it's going to manage these instances. So instead of having one scheduler manage all of those instances now, that first scheduler is now managing shards 0 to 49, which ended up being 16 of the 30 instances. The second scheduler, as we connect to it, is managing shards 50 to 100, and it's managing 14 of the 30. And again, if we really had a lot of traffic, and again, I'm not talking about 30 instances, I'm talking about if you were to pre-allocate, let's say 5,000 instances across a few dozen nodes, and you really wanted to be able to handle extreme number of requests and things like that, you could just theoretically add up to 100 schedulers and have 100 different have one scheduler per shard. So even adding that third scheduler here, now, this instance recalculated, and now it's only going to be managing shards 33 to 65, and this final scheduler is going to be managing shards 66 to 100. So point is, it's very horizontally scalable. We can go back, and we still have our 30 containers. And so let's say I want to scale that up to even more. Now, I don't have auto scaling enabled on this environment, so there's a chance that we're going to get an error saying that we are out of capacity, but there we go. So we're at 40 instances now. So, and then if I go back to the scheduler will have picked that up. So I'm going to click manage instances. I'll just connect one of the schedulers, and there you go. We can see that just deploying those more instances, the scheduler picked that up, and now it's saying, hey, I'm going to manage 15 of those instances instead of 11. So a general idea behind behind these functions is, again, they're short-lived containers that can run anywhere from 5 seconds. So, I mean, technically, I guess they could run for even half a second if they needed to, but they're short-lived, but Actually, maybe I don't want to say that, because at the same time, you could have these functions. The maximum runtime that we've defined for these functions in cycle is 6 hours. So I guess maybe instead of saying that they're short-lived, maybe it's better for me to say that they're ephemeral, right? They're temporary. The idea is that they run, they get reset, and they're ready for the next workload, regardless of whether that's processing an image or encoding a video or handling a video stream or running a game server, whatever that purpose may be. And as I mentioned before, so this demo was just using an HTTP request to kind of trigger a function, but at the same time, as I go over to our documentation, we also have our scheduler API. So the scheduler API allows us, so if, like, suppose you uploaded the container to this environment, you could actually talk to the scheduler directly using this API to be able to claim instances, spawn instances, and release those instances when you're done. And we have a couple examples here. So that way, if you need to kind of schedule things in the background, you can absolutely do that without those functions have anything to do with HTTP requests or anything of that nature. So yeah, like I mentioned, this is a feature that we just launched. There's what it looks like today and what it will look like 60 to 90 days from now is going to be likely very different. But yeah, we just wanted to get this into the hands of our users to see how they use it and figure out where we kind of want to take this functionality. But that's all for the video. If you are, again, new to Cycle, we'd love for you to join our community. You can find that community on Slack. It's slack.cycle.io. And if you have any other opinions or thoughts on functions or any questions on anything you saw today, again, this video is mainly focused on functions. There's too much about Cycle to kind of dive into and along with that. Yeah, if you have any questions, we'd love to hear from you. And yeah, thank you.